What up, little critters? We're going to get started with the live stream. Sorry for the delay. I got a minor setback with some tutoring, but other than that, I'm hanging in there. Got the review all set up. Hopefully the YouTubes is all set up. We should be good to go in a bit. But yeah, no, I'm looking forward to having a good math session with y'all. Again, same as before, I'll just kind of go through the whole thing. If there are any specific questions you have, I'm more than happy to go to those questions. And again, just, I'm here for y'all. I'm here to help. As long as I can get YouTube to work for me. There we go. Yeah. Here we go. Now I just gotta open up the chat box. Cool. All right, got the chat box out. Hopefully I got a couple of y'all asking questions and figuring out the meaning of life. And please not free computer. Okay, cool. Got 4 people watching. That's awesome. All right, so I'm gonna go ahead and start with the first one. Then as questions pop in, we'll kind of go through each of those and make sure that we answer any and all questions that are necessary. So here we go. In all of these problems here on this first set, we assume that AB is tangent, which means that we're going to be allowed to do one thing, and that is mark that we have a right angle here. Right. So BE is 16, AB is 15. We wish to find the measure of AO. So this one is literally screaming Pythagorean theorem, but before I can do that, I've got to use that 16 from the diameter and make it the radius, which is 8. And now we can say 8 squared plus 15 squared equals x squared. Leg squared plus leg squared equals hypotenuse squared. Now 64 plus 225. Let's see here. 289. And when you take the square root of both sides, x is going to equal 17. All right, cool. Number 2, BE, that's again our diameter. The measure of angle A is 45 degrees. We know that the tangent line forms a right angle with the radius. So you're talking out of a potato. So are you saying my volume's not working, Cameron? That's some weird thing to say, a potato? No, I have a microphone, dude. Now you're having me concerned. Hold on. Jeez. Sounds poopy. Wow, thanks, man. No, it does not sound poopy. I'm listening to my own speakers, so you need to check your speakers, dude. All right, cool. So I'm gonna move on without any more distractions. What? How is it hard to hear me? I literally just put my volume on and I'm listening to my YouTube. You guys are killing me here. I literally just heard myself. There was no cutting out. Oh my goodness. You guys are killing me here. I'm just gonna mute it. I'm just gonna mute it. I'm tired. I don't need this. I'm tired, guys. All right, let's move on. Number 5, I have the measure of arc DEF. That is not an angle. There's no angle symbol there. Okay, so DEF, right? Why? I literally just said it's not an angle. So there we go. So from here, we recognize that the full circle has to add up to 360. So this arc right here is going to be 360 minus the 250. So that's going to give you 110 degrees. Now it says the measure of BD. Well, BD is just this arc here. And since these two are congruent, we're going to say 110 divided by 2. So that's going to give you 55 degrees. Okay. Now looking at this one, BF. This is arc BF, that's 80. Right there we have 80. We want to find the measure of angle BEF. So BEF. This is our ice cream cone. You can do SOHCAHTOA, but the problem, Cameron, with that is if you have a calculator that doesn't spit out exact answers, it may not work out. But as long as you get the right answer, that's all that matters. So anyways, for the ice cream cone, right, we're finding the angle. So angle BEF is equal to 1/2 of the 80 degrees. All right. 7, we have FEE, that is an angle, FDE, and we say that this is 70 degrees. So find the measure of FE. So here's arc FE. So now we're going the opposite way. I'm still confused on how you guys took this test ahead of us, Natalie. I don't get it, like, whatever. Anyways, so here's 140 degrees because you double it. You go from the angle to the arc. Now BE, right here, 26. That whole thing is 26. And then we're told that DF is 24. So what we're going to want to look at, since it's asking us to find OX, we're going to want to look at the triangle that's right in the center there. So this is what we're solving for. We can take half of both of those numbers. So I know that the distance from here to here is 13, which since it's the radius, why did I say that part? Wow, I really am tweeting. The 13 right there, our radius, also goes here because that is the same distance from the center to the edge of the circle. We have our 12 there and our variable x there that we're solving. So what we're looking at is a right triangle with two side lengths. Boom. So then we're going to say x squared plus 12 squared equals 13 squared. This is a Pythagorean triple. If you don't recognize it, it's okay, but x equals 5. Okay, so then that is for OX. All right. Next one right here, finding all four of these angles. First theorem you got to remember is when there's a quadrilateral inside of a circle, opposite angles are supplementary. So, oh my gosh, I can't write right now. 70 plus W equals 180. So then you take away 70. So then W is equal to 110. Now, to solve for X, we're going to do our ice cream cone. So let me make the highlighter a little smaller because we're not going to use, we're going to try to use less so that it's not as confusing. There's my ice cream cone. Here's the ice cream. Now, what we're saying is that this X plus 120, which represents this entire arc, you're going to take half of that, and that equals this. Or you could say, hey, let's double that inside angle, which is 220, and set it equal to the arc. Both ways work, you get the same answer. So let's take away 120. So then we get 100 degrees for x. Now for y is this little section right here, and it is formed by the tangent and the chord. So this is, again, our ice cream cone. You're just going to take half of the 80. So y equals 1/2 of 80. Now z, we have a couple ways of doing this. One way that we can do this is we could say, hey, the total outside of your arc has to add up to 360 degrees for the full circle. So we already have the 80, we have the 120, we solved for x earlier, so now we just need to solve for this arc here. So let's see, 110 plus 120 plus 8. Right, so that's going to give us, let's see here, 120 and 80 is 200, 310. So 360 minus that, that'll give us 50 degrees. So this arc here is 50, and to go to the angle, remember we're going to take half of that. So we're going to say here that z equals 1/2 of 50. So then there's our 25 degrees. Again, if I'm going too fast, please ask questions. I know there's 8 of you guys watching, and I know this is late, but I'll take it. What did I do to find y? I took half of the 80 because that's our ice cream cone. All right. Now this one, there's going to be a lot of writing. I am going to erase certain markings. So if for some reason you don't understand how I got a certain answer, just kind of go back to like the beginning of the problem and then kind of watch through each step. So right here, the measure of AE is this part right here. What we have to remember is we have a diameter here. So 90 plus 20 plus what equals 180. So we're going to say 90 plus 20 is 110. That it does not look like a 110. There we go. So we're going to do 180 minus that. So then there's our 70 degrees. And we are going to need this in a bit, so we're going to keep it there. Now we also need the measure of DE, which again, same logic. We have half a circle here. So 100 plus what equals 180? So we're going to get 80 degrees there. Okay. Now the fun part, finding all those angles. I'm going to go in order based on the picture. Okay? Here we go. The measure of angle 1. The first thing I ask myself is, where's angle 1? Angle 1 is outside of the circle. So angle 1, because it's outside, remember we're going to say it's the out minus the in divided by 2. This is our outer arc and inner arc. So again, here's my kind of highlight to show you guys. Here's the inside arc. Here's the outside arc. Okay, so our outer arc is the 90 plus 20 plus 100. So that's going to be 210 minus the 70 plus 80, which is going to be 150. Then we're going to keep going, so that's going to be 60 divided by 2, which gives us 30 degrees. Now, I'm going to erase these highlights right now to help us with looking at angle 2. So angle 2 is right here. Again, I'm asking myself, I'm saying, what kind of an angle is angle 2? And I recognize that it's in the center. So the central angle is the same measure as the arc that is right directly in front of it. So angle 2, no work needed, is 70 degrees. Now, angle 3 is not a central angle. It is an angle that is on the edge of the circle. So we're looking at this arc. Well, going from the ice cream to the ice cream cone, right? Remember, we would say, oh, well, that was weird. It did not want to work with me. It goes towards the vertex. So we're going to take half that arc. So 70 plus 80, we did that earlier, that's 150. So angle 3 is equal to half of it. So it's 75 degrees. We're going to look at angle 4 next. So again, that involves me erasing the markings. So angle 4 we're looking at is right here. And so again, the angle is outside of the circle, so we're going to do our out minus our in, divided by 2. So angle 4 equals 70. My handwriting's not helping right now. Minus 20 divided by 2. All right. Now, looking for angle 5. So angle 5 is this one right here. It's formed by the chord and the tangent line. So this is, again, our poor man's ice cream cone. We're still going to take half of this intercepted arc. So we're going to take half of 80 plus 70 plus 90. So that should be 210. So angle 5. Thank you, iPad. Angle 5 equals 1/2 of 210. And that's 105 degrees. All right. Angle 6, our last one here. So angle 6 is not in the center. If it were in the center, we would have this dot right there. So instead, angle 6 is found by creating, why is my iPad dumb? Okay, gotta be calm and collected. This is the one where we create our bow tie. So remember that with the bow tie, we're looking across the angle and behind the angle. So this is where we take the sum of those two arcs. So we're going to say 80 plus 20, and then divide it by 2. There we go. All right. I'm going to move on now. Hopefully this stuff kind of made sense. All right. GM is 5. MJ is 8. FM is 3. Find the measure of MH. So this is the one I don't know. Well, the lines are inside the circle. They're intersecting. So this is the one where we say part times part. So we're going to say 3x equals 5 times 8. And we can't divide 3 evenly into there, so we simply say x equals 40 over 3. All right. All right, 19. LJ is 2. So let's see, LJ is 2. JG is 7. Find LA. Okay, so we're looking at a tangent line, and we're looking at a secant line. So remember we say that it's the tangent squared equals outside times the whole. Okay, so now here we're going to say tangent squared, which is in this case x squared, equals the outside, which is 2, times the whole length, which is 9. So we're going to have 18. Now, when you take the square root of 18, you can't actually take it perfectly, so you're going to reduce this. Now, I'm going to use the perfect squares method because I know that 9 goes in very nicely, and it's 9 times 2. Right? So I say the square root of 9 times the square root of 2. Wait, the square root of 9 is 3. Then I have rad 2. Oh, yeah. Okay, that's what we do for 19. I'm going to move on to 20. Ooh, this one looks like another outside times the whole. So then LJ is 6, JG is 8, LI is 7. We're trying to find IH, so that's our X. Which one did you get lost on, Cameron? I'm assuming it's this one. Oh, 19. Well, why didn't you? Okay, never mind. I'm on 19 now. Yeah. So, specific, where did you get lost? Because if you don't tell me where, I can't address the problem. You can't say everywhere, dude, because that literally doesn't tell me anything. Okay. So that line FL is a tangent line. A tangent line, remember, is the one that touches the circle at exactly one point. Because it's touching the circle at exactly one point, it's not going inside the circle. Our theorem of outside times the whole just simply means, hey, we're going to do x times x. That's why we say tangent squared. Okay, that's your x squared. Then the outside times the whole, we're saying, hey, the segment that's outside of the circle, and I'm going to erase this to kind of show you, the segment that's outside of your circle, that's this line here. If we multiply that times the whole length, well, the whole length of this line is 2 plus 7, which is 9. So that's the proportion or the equation that we're multiplying. So that's how we get this. X times x is x squared equals 9 times 2, which is 18. Now to get x by itself, you need to take the square root of both sides. Once you've taken the square root of both sides, you'll have x equals the square root of 18, but we can't have the square root of 18. You have to reduce it. 9 times 2 is 18. Why did I choose 9 times 2? Because the square root of 9 is 3, and I can't reduce the square root of 2 any further. So hopefully that helped you. I do need to move on because, again, I'm really tired and I've got work to do still. So we're going to do the same theorem here. So the outside is the 6. The whole length is 6 plus 8, which is 14. The outside here is 7. The whole length is 7 plus x. Please don't put 7x. That'll make me very sad. Uh, 6 times 14, what is that? 84. And then make sure you distribute correctly. Don't exclude one number. Okay, so we're going to take away 49. So what is that? 35. Boom. Okay. Now 21 is another whole mess that's similar to what we did in the previous page. So just again, kind of follow along the markings. I'm going to first find the measure of these missing arcs because I am given a diameter. So with the diameter splitting the circle in half, that means that this arc here is 40 degrees. Just 40 plus 140 is 180. Then over here I have 90 plus 50, which is, ooh, look at that, 140. So that means this left arc here is 40 degrees as well. Okay, so angle 1, we're looking at angle 1, which is on the edge of the circle, and it forms the ice cream cone here. So we're going to take the 50 and take half of it. Okay. Now angle 2, we're going to look at angle 2, which is the angle that's outside of the circle. Boom and boom. So since it's outside of the circle, we're going to do the outside minus the inside divided by 2. Let me make sure I did that right. 140 minus 50. Yep. Boom. Okay. Angle 3. Angle 3 is formed from this tangent and this chord. So this is a poor man's ice cream cone. So then, boom. Angle 3 is going to be half of that intercepted arc. So half of 90 plus 140, which is 130. So then we get 65 degrees. All right, angle 4, let's take a look here. Angle 4 is formed by these two chords intersecting. Huh, it's not in the center, so this means our bow tie. So that means we're going to look outward away from 4 in both directions. So we're going to take 140 plus 90 and divide it by 2. Yes, got 2 free tacos. So 115 degrees. Why does that seem right? That is right. Okay, yeah, no, we're good. Okay, last one, angle 5. Again, angle 5. If you notice, it's right at the center. So that means it's going to be the same measure as its intercepted arc. So that's going to be the same thing there as 40. Boom. Okay. So now the fun one. We're going to be doing arc length. Now for arc length, you have to remember that it's our little proportion. Okay, it's going to be I'm not sure if I use the same symbol with all the classes, but we said that it's the angle divided by 360 equal to the arc length L over 2 pi r, which is our circumference. So the angle we're looking at for DE, it's going to be the short path between the two, which is here. Now that angle of 30, yeah, we use theta, but I don't remember if I did that in the first class. So I'm just writing the word angle. So this is going to be 150 degrees, yeah, because we have a half circle. So we're going to use 150 inside of here. So 150 over 360 equals the arc length over 2 pi times 8. Okay, so I can simplify these fractions before I cross multiply. I could cross multiply first, then simplify. At this point, I'm not going to go any further because really that's going to be a you thing. You have to be able to set this up. But I'm just going to humor the idea of, let's say, oh, this is cross out. Cool. 15 over 36 equals the arc length over 16 pi. You'll cross multiply here and then reduce your fraction. Okay, I'm not going to go any further. I'm going to set up the next one, 23, DFE. So here's D, F, and then E. Okay, so we have 180 degrees here, plus the 30, which should give us 10. So we're going to have 210 degrees over 360 equal to the arc length over 2 pi times 8 again. Why did I say 8? Radius was 4. Yep, that's how tired I was. I was thinking ahead to the answer. Okay. So that we have the 8 pi there. Yep, I'm ready to go to bed. And the iPad is not working the way it should. It keeps glitching. I'm on the last page. We're almost done. Okay, AC is 28. So this entire thing here, 28. ED is 9. So here's 9. We could say this side is also 9. Find the measure of BCD. Okay, so it says measure, so that means our answer has to be in degrees. So here's BCD. Well, in order to find an angle there for the arc, we need to create an angle in the middle. So that central angle is going to go from here to here. Well, you're going to notice that inside of there we have a right triangle. And what we're going to do is we're going to take that 28 and split it in half to make 14. Boom. Well, if that radius is 14, that means this radius is also 14. And remember that we're looking for an angle. Well, there's this really cool thing that you're able to do with right triangles where you can solve for a missing angle. It's called inverse trig. So 14 and 9, here's the angle I'm looking for. So I'm thinking SOHCAHTOA. Well, this is the opposite. This is the hypotenuse. Why? Opposite hypotenuse. So we're going to use sine. Oh my gosh. I am way too tired for this. Sine of x. Okay. So we have sine of x equals 9 over 14. Yeah. To get x by itself, we have to use inverse sine. So then x equals inverse sine of 9 over 14. So then that's going to give you some angle. I don't have a calculator on me. Okay. But what you're going to do is you're going to go ahead and you're going to realize that that angle is only this much of it. So what you're going to do is you're going to double your answer. Okay? And again, I don't have a calculator, so I'm not solving it. You're welcome, Elijah. Things I do for y'all. All right, so this one is 134. This one's missing, but that's okay, because what you can do is you can say 360 minus 134, and that should give you 200, what is that, 26. So then you're going to do your 226 minus 134 divided by 2, and that's your angle. All right. I'm not doing that. I will let you guys finish because I am ready to go to bed. Okay, here, outside minus inside divided by 2 equals your angle. So we're going to have x minus 32 over 2 equal to 25. Multiply both sides by 2, children. So x minus 32 equals 50. All right? Then you'll just add 32. Cool. All right. We got all these tangents. AC is 18. See what else we got. GE is 22. DE is 14. And then CD is 9. Okay. This is where we got to make sure we don't do any dumb mistakes. Okay, mistakes are okay as long as we learn from them, but this is not the spot where you want to do something like this. You do not want to say, oh, here's 22. I'm going to take half of it and say that each side is 11. You don't do that, okay? This 14 is congruent on this segment and this segment. So if that section is 14, take care, Ryan. And the total length was 22. Well, you're going to do 22 minus 14 to get you GF, which is 6. Not 6. Why did I say that? 8. Oh my gosh, why is the iPad being so dumb? Now that that side is 8, we also know this other side is 8. These two are congruent. Now, going back the other way, if we look at the 9, this 9 is congruent to this 9. It just so happens that on this one, the other side is also 9, but that's because 18 minus 9 is 9, not because I did half of 18. Okay, so don't make up stuff. So, if I take the side length here, 9 and 14 is 23. If I take this right here, that's 17. So to find the perimeter, we're going to add all those side lengths together. Why is my iPad being dumb? Okay, so I know that you got a number there. Cool. And of course. Anyways, hopefully that was helpful to y'all. I'm going to go to bed now. I'm tired. I could definitely use some Z's. Anyways, don't stay up late. Just go over the notes, go over the properties, make sure you don't make any false assumptions. And I believe in y'all. This is one of the last tests of the semester of the year. I need you guys to stay strong, finish strong, and work hard. All right? You guys have a good night. And bug me in the morning if you have questions, okay? Bye.